Bam! This is Better Anthony McDonald here to introduce you to your next favorite artist. Ooh, all right. Show on the screen. Can you hear me? Director's voice is on. Is it coming through though? That's the question. Ooh, all right. Hey, we got it. Hell yeah. Show on the screen. Can you hear me? Director's voice is on. Thank you. Hello, is it coming through on Twitch? Hello, is it coming through on Twitch? Yes, it is. Coming through on Twitch. Yes, it is. Coming through on Twitch. Yes, it is. All right. All right, we got it. We good. All right. So I'm happy to be streaming. I had some issues with stream before. I didn't know how to properly use my tools, but we're moving. We got it going now, so I'm happy about that. Working out of the garage, also known as my office, going live from or to Twitch, YouTube, Facebook, and my website. You can chat with me on all the platforms. So that's dope. Next, what are we gonna do? What are we gonna do? You know what? I'm bring up Facebook, so if someone's chatting on there, I can interact with them. So is the caption or the description says I'm working on some Python, AI, machine learning. I bought a class from Udemy that teaches Python for the purpose of doing cybersecurity using AI and machine learning. So that's dope. Yeah, we're gonna trust this device. I got the recommendation from my uncle. He works in cybersecurity, and he says it was a good class to take. He took it, so all right. I thought I'd give it a shot. So let's see if I can. Is my live showing up on Facebook? Oh, yep, there it is. Is the chat gonna come? Yep. Hey. All right. Trying to send something back. There it is. Will it go to all platforms though? Let's see. Yeah, it went to Twitch and went to YouTube. It's not going to Facebook though. That's cool. I'm cool with that. That's whatever. All right. So let's see. What's next? What's next? What's next? So I've watched a few of the classes, going through a couple of the modules, and what I've found is it's a little challenging. I don't know if you've ever taken a class from someone who has an accent. So that's one of the things I'm struggling with. But they do provide transcripts. There's captions on the videos, and then they have documents, which basically walk you through everything in the videos. So that's good. I appreciate that. So, and also have sample documents. So section is about implementation of the Markov chain. If you're not familiar, they provided some documents that describe the Markov chain, but here's what ChatGPT says about it. Pretty similar. Markov chains are mathematical models used to describe systems that transition from one state to another within a finite or countable set of possible states. In the context of artificial intelligence and machine learning, Markov chains are frequently applied in areas where the future state of a system depends only on its current state and not on the sequence of events that preceded it. Known as the Markov list fit. Wow. My is being and if you're familiar with sport, like strategy, how it's used football, for example. What happened play before isn't as important as what happens in the current play to the next state, right? You could have had a big run or a big play that got you 30 yards and you're on the 20-yard line going into the end zone, but that doesn't matter because what happens next to get you to the next state, which might be right now you're 1st and 10, but might get you to 2nd and 3 or even a touchdown, is what you do in this current state. The fact that you're on the 20-yard line increases your odds of getting into the end zone or getting to the 10-yard line, right? And it determines, and the fact that your current state is that you have the ball 1st down on the 20-yard line going into the end zone, and there's 2 minutes left on the clock. All these things that describe the current state are what matters, not everything that happened previously, right? You could have had a horrible game all day, right? Just nothing worked all day. But because you're in this current state, you could possibly win the game, even though everything else is going wrong, right? And an example in basketball would be, right, you have a horrible game, but it's 3 seconds left and you're only down by 2. You have a chance to win the game, right? You could have missed every shot prior to that. You could have dribbled off your foot every time you touched the ball. You could have gotten the ball stolen from you, fouled and hacked all day long. But because there's 3 seconds left and you have the ball and you're only down by 2, you have a chance to win. So that helps me understand Markov states. It's memoryless. And in sports, they talk about having a short-term memory because you need to focus on the play at hand, what's happening right now. And that to me is an example of the memorylessness of Markov states. It's used to describe the usefulness of it, or the way you can apply it. Uh, Stock markets, predicting how the market will change, whether it's going to go up or down, whether there's going to be a crash or things of that nature. Another example of how you could use it is predicting the weather, right? If it's 70 degrees today and the sun is shining and there's no clouds in the sky, then you can use this information that you have right now to predict what the weather will be tomorrow, right? The chances of being sunny tomorrow, because it's sunny today, could be 70% chance of sunshine, a 20% chance of rain, and a 10% chance that it's going to be cloudy, right? All based off of what is happening right now, not what happened yesterday or anything else, but that's a simplistic, I believe, an example of it. Other ways in which you can use a Markov chain is systems for business, a queue system as far as the processes for handling customers, moving them from one state to another, from being someone just interested in your product to someone who signs up for more information, to someone who is developing a relationship with the salesperson, to someone who has purchased and now they're dealing with the relationship management as far as an onboarding coach with the product. And then it's the state then, and each one of those states you can predict the chances of them getting from one state to the next based off of the fact of what state they're in now, right? So there's different ways of doing it. Another example of using Markov state. Let me look at some of the examples. Okay, so instead of talking about more examples, we could talk about how you would model it. I described some ways in which it was linear, right? You would go from 1, 2, 3. That is what they would call that. There's four different. The class say that there's four different types of Markov chains: discrete time Markov chain, continuous time Markov chain, absorbing Markov chains, and ergodic Markov chains. I read those from the sheet, the resource sheet that was supplied for the class. I'm going to try to explain them without reading them from the sheet. A discrete time Markov chain is a chain where the state changes at specific times, so it's predictable, right? An example would be your work schedule or your class schedule. If you're in high school or junior high, you know at 8:00 you go from first period to second period, and then you just move through your state that way. It's 1, 2, 3. So that's when the time happens. When it hits 9:00, it's now time to move from one state to another, right? And then when 11:00 comes, you now know it's lunchtime. So you move from the classroom to the lunchroom state. And another example of a discrete time state would be in a manufacturing facility. If you're building or manufacturing goods, right? So a product or your resources might sit in a particular process or a particular state within the whole process for a certain amount of time, right? It's 2 minutes in the drying phase. Then maybe an hour in the packaging phase, right? And then maybe there's another 30 minutes in the state where you're preparing it to be shipped out of the facility. A continuous time Markov chain is there's no specific time in which things change. It kind of just flows continuously. There are no fixed intervals for things. An absorbing Markov chain is when you get to a certain state, and then that state, you don't leave that state. So if you get to a specific state, or everything eventually ends up in one state. I guess you could, an example of that would be, I guess though, when I first read it, the first thing that popped into my mind was poverty. So in a capitalist world where it's strictly capitalism, a majority of the individuals from the outside looking in, from my observations of it, it seems that more and more beings move toward poverty, right? As resources are hoarded by one group, then the other groups are left with less and less, and they move towards poverty. And then there's a ergodic, I believe I'm pronouncing that correctly, ergodic Markov chain, and that's where it's possible to get from one state to any state. They have a long-term, and it's a long-term, stable, stationary distribution. So I need to talk more about stable distribution a little bit later on. An example of that would be someone with lots of confidence, right? They believe that they can get from where they are to any place that they want to get to, and all things are possible. So that was the first thing that came to mind when I read that about ergodic Markov chains. Let's see what else. See an example. I guess another use case for Markov chains is PageRank on a search engine, right? Because when someone searches, you're predicting. You use Markov chains to predict or find the probability that something will change from one state to the next. And an example of using a search engine would be, or PageRank would be, someone puts in search terms, and then what comes back, what you show the person searching, is the websites that you believe that they're most likely to go to find the thing that they're looking for. It can be used for speech recognition. So based off of the current word, you can predict the next word that will be said. So in the example I'm gonna do in a little bit, we take customer reviews and try to predict new customer reviews. It can be used for biology and genetics to predict the sequencing of DNA and the spread of disease. And also in game theory, predicting the decisions that people will make in games, whether it be board games or card games, or just a sequence of events. Benefits of a Markov chain is that it's simple. The concept, it's simple to fathom, to think about. It's versatile. It can be applied in a lot of different areas. And the predictive power of it, it's useful for forecasting behavior in systems with uncertainty. Limitations. The class, the documents list 3 limitations. One is the assumption of independence, assuming that only the current state has an impact on the next state, which isn't always true, right? Or the current state may not have as big an impact on future states as one might assume, right? State space explosion. But that is like for complex systems, there can be a lot of different states, including infinity, and an infinite number of states, which can make computation challenging and difficult. and stationary requirements. I need a better understanding of that one. It says that some models assume a stationary transition probabilities, which may not be realistic in dynamic environments. So let's go ahead and look at what ChatGPT says some of the strengths and weaknesses are of Markov chains. So again, for strengths, probably gonna give us about 4 weaknesses as well. Let's see. Oh, even tell us when to use and when not to use. All right, so let's go back and look at our list. Strengths, Markov chains, while powerful and widely used in AI and machine learning, have both strengths and weaknesses depending on the context in which they are applied. Here's a breakdown of some of the pros and cons. Strengths of Markov chains: simplicity and efficiency, easy to understand. The Markov property makes them conceptually simple because future states depend only on the current state. This simplicity makes them easy to implement and computationally efficient, especially for problems with relatively small state spaces. Low computational costs. Since Markov chains do not require keeping track of long histories of states, they tend to have lower computational overhead compared to models that rely on long term dependencies. Okay, went over that earlier. Applicable in sequential and time series data. Nature of sequence data. Natural for sequence data. Markov chains fit well with time series sequential data and processes that evolve over time, making them ideal for modeling things like language sequences in NLP, user behavior, or stock prices. For example, predicting the next step in a sequence or modeling transitions between states is a natural fit. Foundation for advanced models. Extensible to more complex models. Markov chains form the basis of more advanced models like hidden Markov models and Markov decision processes, which are commonly used in tasks like speech recognition, reinforcement learning, and gene sequence modeling. Versatility, they can model both discrete and continuous states, making them flexible across many domains. So it's foundation for more complex tools. So this tool can be used as the foundation for other tools that are more complex. Okay. Interop interpret interpret interpretability, easy to interpret, interpretability. Markov chains are often easier to interpret compared to more complex models like neural networks. The state transition probabilities provide clear insights into dynamics of the system. Okay, so okay, it's easy for people to understand what's happening in the model. All right, weaknesses of the chains: memoryless property, Markov assumption, limited context awareness, limited contextual awareness. Markov chains assume that future states depend only on the current state and not on the full history of previous states. This memoryless property can be too simplistic for many real world problems where the past history significantly affects future outcomes. For example, complex language tasks where meaning is carried over several words and or sentences. Yeah, this was one of the things I thought of at first when I saw that it was used to predict speech or the next word in in a sentence. Knowing the current word doesn't give you a lot of context for the sentence or the conversation. So, and you'll see in some of the examples that we do later on in the predictive text that the sentences are sometimes nonsense, just hard to understand what you're trying to say. Another example is inadequate for long-term dependencies. This limitation makes Markov chains poor at capturing long-term dependencies in sequential data in natural language processing, for instance. They struggle to model complex sentences structures that rely on distant words for context. State space explosion, scalability issues, state space explosion. For large state spaces, Markov chains can become impractical. The number of possible transitions increases exponentially with the number of states, leading to memory and computational deficiencies. This is particularly problematic in models with large vocabularies, complex action spaces, or continuous states. Sparse data problem. In real world scenarios, the transition probability matrix can become sparse as there may be many transitions that rarely or never occur. This can lead to inaccurate modeling or the need for significant amounts of data to estimate probabilities. The transition probability matrix can become sparse as there may be many transitions that rarely or never occur. Okay. So I guess it'll have a lot of states, and then many of those states have a low probability of occurring, and the model will show that they have a low probability because there's little data on those states. But in reality, those states may have a higher probability than the model can predict because it doesn't have enough data. That's what I'm thinking that means for weakness. Assumption of stationarity. Static transition probabilities. Markov chains assume that transition probabilities between states are stationary, meaning that they do not change over time. In many real-world systems, however, the dynamics of the system evolve. User behavior on websites might change over time, or stock market conditions shift. This static assumption can limit the effectiveness of Markov chains in non-stationary environments. Okay, I understand the stationary assumption now, or assumption of stationarity. Basically saying that the probabilities should evolve and change over time. Like you can't just print out a matrix of states that are possible and assume that those will always be the same. It's not like a map where you can go and grab an atlas or pick up a map at a gas station and keep that map forever because those cities will always be there. Like Chicago isn't going to change where Chicago is. Like you'll always be able to take the same highway to get to Chicago, barring any maintenance on the road. But you get what I'm saying. Lack of flexibility for complex models. Limited expressiveness for problems involving complex interactions between states. Non-linear dependencies. Lack of flexibility for complex models. Limited expressiveness for problems involving complex interactions between states or non-linear dependencies. Markov chains often fail to capture the underlying structure. Markov chains often fail to capture the underlying structure. More expressive models, such as deep neural networks, are better suited for these types of problems. All right, so if it's a simple model, then you can use a Markov chain, but if things are complex, if it's a complex model, then you want to do something else. Difficulty in modeling multiple features. Markov chains typically model a single state variable, and extending them to handle multiple features or high dimensional data becomes challenging. Okay, so an example would be so I guess to go back to the sports analogy where I said that the state of being at the 20-yard line going into the end zone. And then I started naming all the other factors of it being 2 minutes left in the game. It's currently 1st and 10. And the fact that you're going into the end zone and you're down by 6 points. All those other features, all those other details make the model complex. So if you just focus on the fact that you're on the 20-yard line and that's it, that information with a Markov chain would be ideal. It's a single state variable, and then you can predict what will happen next or where you'll go next. Overfitting with small data sets is the fifth weakness. Overfitting with small data sets, overfitting risk. With small data sets, estimating transition probabilities accurately can be difficult, leading to overfitting. This is particularly true when the system has a large number of possible states, but limited data to support the estimation of transition probabilities. Summary of strengths and weaknesses. Strengths: simple, efficient, and easy to implement, well suited for sequential and time series data. Foundation of advanced models, the hidden Markov model, and the Markov, what's the MDP? Markov decision processes. Computationally low cost because it doesn't have a memory. You don't have to worry about collecting a lot of data. Just know what the current state is. And interpretable with clear transition dynamics. Weaknesses: cannot handle long-term dependencies, state space explosion with many variables, assume static transition probabilities, inflexible for complex nonlinear problems, overfits with sparse or limited data. When to use a Markov chain. Markov chains are a great choice when the problem involves sequential or time series data with short-term dependencies. Computational simplicity and interpretability are priorities. The state space is relatively small and manageable, and stationary constant transition probabilities is a valuable assumption. Stationarity, constant transition probabilities is a valuable assumption. When not to use Markov chains. Markov chains might not be ideal when long-term dependencies or complex contextual information need to be modeled. The state space is too large, leading to a sparse transition matrix. The system evolves dynamically over time, non-stationary environments, and nonlinear or complex relationships exist between states that require more sophisticated models like neural networks. All right. What else can we do? Let's go ahead and get into the document or the example. All right. So I'm using the Google Colab research tool, pulling the data that I put into my Google Drive. So I'm going to import google.colab into my drive. Import drive from google.colab, and then drive.mount content drive. All right. So it's already mounted. I did that earlier. You'll have to give uh, this tool permission to access your Google Drive as well. So be ready for that pop-up if you do this. All right. Then I'm going to CD into the collab folder. Excuse me. Next, I'm going to use PIP to install Markovify. All right. That's done. Next, import Markovify. What do we got an error about? The file name. So I renamed the files so that they have, so I'll know where to find them, or I know which section of the class they're referencing. This is different. File not found. So it's still the same file not found. Oh, okay. So maybe it's not in the folder. Yep, that's it. So let me put the file in the Colab folder. I need to move it. Give me a second. All right. I don't know why it's not letting me. Like I used to be able to just like move these very easily. We're gonna figure it out. Brother gonna work it out. Oh, this is annoying. Okay. Did that work? Could just want to put that in the trash. Okay. Finally. All right. Now we should be able to run it. But it's there. Maybe this will help refresh it. Okay. Still foul enough. Let's try changing the name. No such directory. Airport. All right. Maybe it was spelled wrong. Still nothing. I don't know. Reconnect Google Drive. Now it works. I guess I have to reconnect Google Drive if you make changes within your Google Drive. All right. Let's see if it finds this file. Yeah. Markov is a simple, extensible Markov chain generator. Its primary use is for building Markov models of large corpora of text and generating random sentences from that. This means that it can take some text data and generate text from that, which resembles the original source. I don't know what this word means, so I'm going to look it up. corpora. Define corpora. A collection of written texts, especially the entire works of a particular author or a body of writing on a particular subject. Okay. df.head. So the head is just the beginning is what it's saying. So df, this is Python. So import pandas as PD. So this turns pandas into a shortcut or an alias name PD. Read CSV is a method. So it reads the file, the CSV file that I struggle with finding, and then assign that the contents of that file to df for data frame. And data frame.head or df.head with the passing in the number 3 gives you the first 3. And what would you get if you don't pass it anything? You would get the first 4 by default. So the first 3, 0, 1, 2, because computers start with 0. The airport is tiny. It's certainly tiny. And then we don't get the rest of it. There it is. The airport is certainly tiny. Arriving there good off the plane straight onto the connecting bus to Brussels. So these are 3 reviews for the airport. All right. So next, from Enter Tools, import chain. So n equals 100, review subset, data frame, content from 0 to n. So from the beginning to n. Assign that to the subset. So take the data frame, which is this here, the entire file, and the content of that, and give me first whatever. So 100 is in 0, 100, the first 100. Assign that to review subset, and then create a new variable called text. And what we're going to do is we're going to join all of these reviews, all 100 of these reviews. And because it's an empty string, we're essentially going to make a very large string from it. So that's what chain means, bring them all together. From iterable, the iterable is this array, which is subset, review subset. Assign that to text, and then Markov chain model, Markovify.text. So basically take the text and make new reviews. Enter tool is a Python model that provides various functions that return iterators, which can be used in loops or to create more iterable objects. So that's this. Chain takes an iterable and creates more iterables, or it can make more iterables. The chain function allows multiple iterable objects to be treated as a single combined iterable. N equals 100. Just assign the value 100 to the variable n. You review subsets, data frame, content. Select the first n rows from the content column of the data frame. The DF is assumed to be a pandas data frame, which is a 2-dimensional labeled data structure with columns potentially of different types, and it allows a wide range of operations like slicing, indexing, etc. Text. So basically we're going through now, we're explaining each line of this code. So this treats all items in review subset as separate iterables and chains them together onto one iterable. The empty string join part, then concatenates all the items in this iterable into a single string with no separator between items. Markov chain model, Markovify.text uses the library Markovify to create a Markov chain model from the text string. Markov chains are a type of statistical model that predict future states based on current ones in the context of text. It is simply a way to generate new semi-random text based on the input text. So for I in range of 5, so basically it's like a for loop, or is a for loop going from I to 5. So going from up to 5. So create 5 new reviews. Print Markov chain model, make sentence. So our new Markov chain model from the first 100 reviews about the airport, we're going to make 5 new reviews. And here we go. All in all, it was okay and not a forgery. It was easy to spend more than the older one and also displayed in English. See, that's what I was talking about, where the sentences were nonsense. Like, I don't really know, what are we talking about? Lines are short, and there may not be an issue. If there was also no mailbox after the security check, definitely are, right? Train bus connections are not overly friendly. Once you go through baggage claim area using numerous escalators, in common with much natural daylight and plenty of space to sit, etc., bathrooms are relatively clean. Hey, what are you talking about? Generate 3 sentences with a length of no more than 140 characters. So this is, I guess, trying to create tweets of some sort of, or comments with a comments with a fixed length or a max length. This was going to create 3, so 4 I in a range of 3. Print Markov chain model, make short sentences, 140. The new shops, toilets, restaurants in the hands to avoid missing the flight, landing and baggage efficient and quite quick. Signs throughout the airport are dirty. The waiting is okay. The language pick up and down escalators in a design combining multiple walkways and escalators. Oh, it's not doing it because I didn't do these other ones. So let's see this is what came with the file. Let's see what it predicts or what it can produce. Again, a long wait at passport control. It is a nightmare this morning. This meant that I almost missed my staff. It's gone a long walk. It's gone a long walk to end of Pier A. Then you're in for returning flight was boarded in zones, and this was mainly pre-security, as was baggage retrieval. Luggage took a bit odd with long walks, changing levels 3 times up and down escalators and long corridors. Those are better than the previous. And then let's see for the short sentences. Almost a week later, and no indication at all. Some nice officers and off to the other for non-Euro people. The cafes are good and reasonably priced. Train link into central Brussels. I recommend flying out of the Sabina's frequent flyer status of the airport. So that's a little bit about Markov chains. Again, they're great for Markov chains are used to predict the next state based off of what is known about the current state. They're good when using single features, when simple systems. So not for complex systems, or when you need to consider a lot of variables. When you need to consider more than just the current state, it wouldn't be a good idea to use a Markov chain. It's used or applied in processes within businesses. whether it be the sales process or some other process within your business. Gene sequencing, biology. It's been used for cues and lines, predicting the weather, stock market are examples when it has been applied. Things to be wary of, or weaknesses in it. Assuming stationarity. That is when you assume that the probabilities won't change over time. So there's a lot of systems where that will be the case. For instance, some we mentioned earlier, stock market, DNA, gene sequencing, those things could be changing over time. Other examples are when you can use it, the weather, predicting the weather. Strengths. It's great when it's a single variable or single factor that you're considering when determining future states. It is has good predictive power, great for it simplifies complex systems. Let's see. Efficient. And sequential and time series data, a foundation of advanced models, and interpretability is easy to interpret. Be wary of space explosion, again, stationarity, and it has a lack of flexibility for complex models and overfitting with types of things are data time or date time sequential Markov chains, continuous Markov chains, absorbing Markov chains, and ergostic. Is that how you pronounce it? Ergodic Markov chains. Ergodic Markov chains is when it's a high probability of going from one state to any other state. Absorbing Markov chain is when everything eventually moves towards one state. Continuous Markov chains is when it tends to flow and there's no set time where you're going to change state. And then there's discrete time Markov chain. And it's when state changes a specific time. Definitely going to continue to push on with Python, machine learning for AI with cybersecurity. If you got questions, definitely come back and check out more of what we're doing over here. Sign up at WitUS.Online. There's a form there. You can sign up to join the waitlist, to join the community, or you could text. Go ahead and send a text to, where's the number? Do I not have it out? Oh, it's about to come up. It's on the ticker. So subscribe to our channel and shop with us at awesomewebstore.com. Hit the like button and definitely hit the subscribe button. Join the community waitlist at WitUS.Online. That's WITUS.ONLIN, WitUS.Online, and text SENT to 833-752-8102. That's CNT as in Centenarian, as in 1 cent, to 833-752-8102. And I'm training to be the world's fastest centenarian. A centenarian is a 100-year-old person, as in 1 cent, one hundredth of a dollar. 100 cents make a dollar. So that's the easy way to remember that. And the race ain't for some time, but I've already am heavy into my training. The next stage in my training is going to be picking a race to train for. The race that I'll be running when I turn 100 is the 100-meter dash, but I am choosing to train for the 400 now, the 400 meter, because of its benefits that I can then translate on to the 100 when I run that. So you need to have a lot of power and endurance and power over an extended period of time to run the 400 well. And I believe that'll help me at the 100, especially when I get towards those last 10 meters of the 100. I'll be able to push strong for the training because of the training I do for the 400. Talked to my cousin last night about it. He ran track. His brother ran track. His son ran track. So and they are, from what I understand, the only family that has 3 state champions in one event in the state of Indiana. And they're in the Indiana State High School Hall of Fame for that. So I got a little bit of information from me to share with him what my plan is. He said I'm on the right track. So I'm going to keep going. Downloaded a workout from the trackandfieldcoach.com website. And I'm going to follow it. It's right now I'm starting the off-season workout. And after I do the 6 weeks of the off-season workout, I'm going to transition into the 400 workout, which I believe is about 10 weeks long. And I'm looking forward to it. I'm excited about it. I need to find a place near me to train. I'm looking for a place with a hill that I can run up and down because the 400 workout asks for resistance running. So running up a hill. So I have about a month and a half before I need that. So I'm excited. If you are, well, I have a question for you. When did you realize or know that you were going to live to 100? And what plans do you have for a 100-year-old you? My plan is to become the world's fastest 100-year-old person. And so I'm going to run the race. Maybe it'll be on my 100th birthday. Maybe it'll be a little bit after that. But that's one thing I plan on doing. And I have a grand picture of what I want my life to be when I'm 100 years old. And right now I'm working backwards from there. Like, what all do I want to accomplish? Who do I want to be? Who do I want to be with over that time? And what experiences do I want to have over that time? So that's what I'm working on. And I'm building a community around that. You can join the wait list. Visit WitUS.Online at WitUS.Online to 810 to join the wait list for the community. And in the meantime, you can shop with us, awesomewebstore.com, and you can subscribe and like these YouTube videos or Twitch or Facebook videos, wherever you happen to be finding and watching this. And a while back, someone asked me why I document so many live shows. What's that all about? And that has to do with my goal to be the world's fastest centenarian. Listening to live music is good for the brain, and having a strong mind is good for living a long, happy life. So it gets the brain stimulating. The fact that you can't predict the next sound or the next note or the next rhythm that the artist is going to play in a live performance, it challenges the mind. So I like going to live shows, listening to the shows, and then sharing those so that, you may not have seen it live that time, but hearing it for the first time is like a live performance for you. So you can help your mind and stimulate your brain that way. So go ahead and check out some of the live shows on the 6 and the 602 podcast. Got more episodes coming soon. Most of them are on YouTube right now, but more are coming to Spotify and Apple Podcasts. And check out the Hip Hop Axioms. Hip hop has had a large impact on my life, and it will continue to have a large impact on my life. A lot of the jewels, I call them hip hop axioms, but the jewels that I find in the lyrics have helped me. have helped me over the years, and I believe they'll continue to help me grow as a person and become better at being a human. So I'm looking forward to the journey. I hope that you join me, join the community, visit WitUS.Online and fill out the form, or you can text CENT. That's C as in Centenarian, E as in everyday, N as in number 100, and then T as in 10 times 10 equals 100. So CENT, text CENT to 833-752-8102. That's 833-752-8102. And I am out. Peace. Remember, you can't stop the bum rush. Be the bum rush and spread love the hip hop way. Peace. And before I go, I'm going to share a show from one of the last Wednesdays I attended. This is Alex Krim. Hope you enjoy.
Check 1, 2. Hello. Test, test. There are days I don't believe that I can even get out the door. Yeah.
Check. Whoa. Check testing. Check testing. Check testing 1, 2, 3. Check. There you go. Hello, Crescent Ballroom. Thank you guys so much for coming out. I am your acting host right now. My name's Alex Krim, and I have a very special friend today here. This is Mike Stocksdale, everybody. Woo! Mike traveled from a faraway land, Los Angeles, city of angels, dare I say. All right, let's give it up one more time for Mike.
Hey everyone. Yeah, I'm gonna play a few songs for you guys. This first one here is called Thunder. It's kind of about perception, and when you think you're not sure if everybody else is seeing the world the same way that you are. Who knows? Maybe you are. Maybe you're not. We're gonna find out. It's called Thunder. There are days I don't believe that I can even get out the door. When the clouds are rolling in and I can hardly see the sky anymore. And the wind and the rain gets a pound of my soul, like a hurricane come from me out of control. And it seems like the sun's been shining on you every morning. Am I the only one who can see the lightning? Am I the only one who can feel the thunder? Every minute, every hour, every single day of the week, my head has got a million thoughts inside it, but I can't even speak. Oh, and I'm stuck like a fly on the wall of your room. So scared I might wreck it all if I move. I could take to the air, but I'd rather not ruin the groove. And I'm the only one who can see it right now. And I'm the only one who can feel the thunder. Well, I know it's a beautiful light. Oh, but sometimes the darkest parts can seem so damn bright. So how do I overcome this spell? Riding a lonely carousel, spinning around and around, stuck on the ground with a storm coming at me. Don't slow down, oh no. Who can see the lightning? Am I the only one who can feel that thunder?
Hello, hello, hello. I wonder if the director will work now. It's working, it's true.
Thank you.
Yes.
Thanks a lot. Thanks, I appreciate that. Thanks to Alex for having me. Alex Krim's coming up next. Don't you worry. And thanks to Jesse, and thanks to Wednesday. This is fun. I appreciate you guys having me. This next song is a 3 a.m. song. If you've ever written a song before or done anything creative, you might know what I mean. I awoke one night and I couldn't get back to sleep. And the only thing I could do was just get up and write some stuff down. And I was worried about my job, or whether I should continue doing that. I was worried about friends that I'd lost. I was worried about my kids. And that day I had seen, it was a couple of years ago, late August, and I had seen this post that Paul McCartney put up about Charlie Watts. It was the day that Charlie Watts, the drummer from the Rolling Stones, died. And Paul had this post, and he was talking about all the things, and he was saying that he was sad, but he didn't look sad, he didn't seem sad. He was just kind of doing it, and it kind of reminded me of how I feel when I experience loss, and I try to kind of push it down and ignore it. And all that stuff, I wrote all that stuff down. I was able to get back to sleep. And then I woke up the next morning, and I looked at these notes, and I was like, I think I could make a song out of that. So I did, and I made this song here called Gone, Gone, Gone. And I'm going to play it. Here it goes. We lost Charlie Watts today. And Paul McCartney, he sure looks sad, but he wouldn't say it. I know our souls, they must depart. Yeah, but me and Paul would rather hold them in our hearts. Where will we go? It's all gone, gone, gone. Where will we go? It's all gone. And I lost a part of me today. Cut out a piece of my heart with a pen upon a page. 'Cause some days you don't believe you have it, and though you can, you don't reach out enough to grab it. Where will we go? It's all gone, gone, gone. Where will we go? It's all gone. No one knows. if you met my sons, I know you'd see it. There's no way to look back and wanna do things differently. There's no world without them in it, I swear, goddamn. Yeah, it took me a long time to get it, but now I understand. Where will we go? And it's all gone, gone, gone. Where will we go? And it's all gone. Birthday. Man, he was a legend, but you probably never knew his name. And Mike once told me to write more love songs, so I did. I bet he never knew how much he meant to this dumb kid. Where will we go? It's all gone, gone, gone. Where will we go when it's all gone? It's all gone, 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 gone. Where will we go? And it's all gone. Nobody knows that ain't bad. We don't go looking for the things we have. We don't go looking for the things we have. No, we don't go looking for the things we have. Thank you. I think for this last one, I'm bringing up Alex Krim to do a little duet. Give it up for Alex. So, if you write enough songs, you learn in your old age that if you put people's names in the song, this is something I've learned recently, you put people's names in a song, they sort of creep out of the woodwork and start messaging you and DMing you on the socials and the internet. It's a funny thing that I didn't know that's a thing that happened. And it just so happened a few years back, this lovely lady, Alex, DM'd me. And she said, hey, you wrote a song, and this is like a song that's all about me. And I was like, no, it's a song about me. This song's not about you. She's like, it's called Alexandra, and that's my name. I was like, well, you know, okay, you believe what you want to believe. And, you know, it turns out she's a musician, and she wanted to produce some songs, and she hired me, and we made a bunch of great songs together, and the rest is history. So I recommend songwriters to write a song with someone's name in it. Anybody's name, and good things can happen. What do you think about that?
Mike's my music mentor now, so guys, write songs with people's names.
So we're gonna do a song called Alexandra, which is what I was talking about before. Give me a second to capo. There we go. Give me a second to thumb pick. Is this your dream? Are we realizing your dream right now?
This is my music full circle, guys. This song right here.
Everyone's like, yeah, okay. All right, without further ado, here's Alexandra. Thank you all so much for listening. My name is Mike Stocksdale. I might do a song with Alex, actually, when her set comes up next. So here we go.
Scroll to right. And right here.
She went off like a firework in the sunset, and packed up in a flash and hit the road. Made it all the way to California yesterday, but back in Indiana, I'm alone. Alexandra, I can see you walking backwards as the sun sets on the cliffs of Palos Verdes, where the world ends. We'll begin to find the answers as the ocean meets the land. Close your eyes and feel the sand. I'll remember Alexandra if I can.
She rents out a studio in Venice, headlines down a trip on Friday nights. And every now and then she'll write a song about the end. At least someday you think I might.
Alexandra, I can see you walking backwards as the sun sets on the cliffs of Palos Verdes where the world ends. We'll begin to find the answers as the ocean meets the land. Close your eyes and feel the sand. I'll remember Alexandra if I can. Yesterday I dreamt that I saw you singing, lonely on the streets of Hollywood. Nobody really heard, so I tried to memorize the words. But Alex, you were gone before I could.
I woke up searching for that faded sorrow. I closed my eyes and tried to dive back in. Sometimes all you need is a reminder that you bleed, to realize that we're alive again.
Alexandra, I can see you walking backwards as the sun sets on the cliffs of Palos Verdes where the world ends. We'll begin to find the answers as the ocean meets the land. Close your eyes and feel the same. I'll remember Alexandra. I'll remember Alexandra. I will remember Alexandra if I can. Thank you.
Let's give it up one more time for Mike Stockdale and for him driving from LA to come be here with us tonight.
If you're in Tucson this weekend, I'm at the Tucson Folk Fest all 3 days, so look me up. Tucson! No? No.
So we're gonna switch it over to my set right now, but Mike, I'm Alex. Mike helped me so much with music. He got me started in music, and we did a cover together. Does anybody here like Lana Del Rey? So him and I did a cover together, Norman fucking Rockwell, and I want this mic off.
Okay, cool. Okay, I can see the circle.
All right, I'm gonna play some songs for you. Sorry about that. This song's called "Love Too Much." We all right.
Howdy, everybody. My name is Wheelwright. I'm going to play some songs for you. Sorry about that. This song's called Love Too Much. Oh, how can I be without the balance I need, she said. I'm just uneven. I'm just uneven. And I'm looking for who loves me best. See, I've given my heart to the wind and I regret it. Blew it back and put it on my face. And I've tried to love someone who was broken by the sun, who was promised to themselves, I guess. I believe in what I am. Just the girl that loves too much. Oh, how can it be? I sit atop the world I see, she said. I think I'm broken. I think I'm broken. And I wish that I could hold a grudge I confess. See, I've been around this city and I've seen how others live. They resent the ones who hurt their soul. How I wish that I could hate someone, but my time is better spent if one of my summers could protect him from the cold. And I believe in what I am. I'm just the girl that loves too much. I'm just not meant to be as loved as the love I toss around. Oh, the light that shines the brightest puts no shadow on the ground. So nobody knows its shape because it blinds the ones who look. So it's alone in all its beauty, undefined and overlooked. I believe that's what I am. Just the girl that loves too much. I believe that's what she is. Just the girl that loves too much. Thanks, everybody. How you doing? It's Wednesday night. You know what that means? It means I'm going to play a song for you. I just got to figure out which one I want to play. I'm gonna do this one. This is a love song about Arizona. If you guys are from here, then you'll know what the fuck I'm talking about. I'd like to come and see you if you've got the time, but I know these days that shit's in short supply. It's just that I'm leaving here tomorrow. We thought I left today, and a few more hours with you could fix me up anyway. So put a rainstorm in my pocket, I'll take the desert where I go. Cause back east they think their rain is sweet, but they don't got creosote. And I'm reckless in my nature, I'll take every shot I get. I'd take your eyes in the creek back home, out of everywhere I've been. folks live out in Queen Creek. You said it's all the same out there, but the 60 runs right in through town. You could meet me anywhere. At this point, you're like home to me. You got me feeling like a stray. And the summer's got us fucked up. It gets harder every day. Put a rainstorm in my pocket. I'll take the desert where I go. 'Cause back east they think that rain is sweet, but they don't got creek. So I'm reckless in my nature. I'll take every shot I get. But I take your eyes in a creek back home out of everywhere I've been. La 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 la. At nights when I get lonely, I look up at the sky. I'm close to you compared to all the effervescent lights. Hell yeah. Everybody say hell yeah. You guys having a good Wednesday? It's so great that we have two of them. It's Wednesday here. Thank you very much for being here. Once again, my name is Wheelwright. I'm happy to be playing for you. I'm trying to talk while I figure out what I want to play next. I'm gonna do. I'll do this one. I'm gonna do this one. I've been feeling numb, shaking at the knees and talking with my thumbs. I've been feeling numb, but it's just the way it is when I'm gone. I can't get enough. Get me out tonight and spin me round and mess me up. Give me all you've got. It's just another way you've given up. Use me up. Maybe I'm yours. Fuck me up. And baby, I'm yours. I'm yours. I can't get enough. I can hardly sleep, lying in your bed beside the things you think you need. Corners I've been backed in, photos we've been tagged in, stuck in the in between. And you're making it hard to leave. So use me up. Maybe I'm yours. Fuck me up.